In today's video, we'll learn how to expand a 3 by 3 determinant along its rows and columns. So let us expand this determinant along the first row. Determinant of A is equal to minus 1 to the power 1 plus 1 A11 into determinant obtained by hiding the first row and the first column of the original determinant. It will be now A22, A32, A23, A32 plus minus 1 to the power 1 plus 2 A12 and the determinant made by hiding first row and the second column. It will be now A21, A31, A23, A32 plus minus 1 to the power 1 plus 3 into A13 into determinant A21, A31, A22, A32. Now this is the sum of row number and column number of the key element, that is A11, and this one is the 2 by 2 determinant by hiding the first row and first column of the original determinant. Similarly, this is the sum of row number and the column number of the second element of the first row, and this is the 2 by 2 determinant obtained by hiding the first row and the second column. Similarly, this is 1 plus 3 is the sum of row number and column number. This determinant is the 2 by 2 determinant obtained by hiding the first row and the third column. Now it will become A11 into A22 into A32 minus A32 A23 minus A12 into A21 into A32 minus A31 into A23 plus A13 into A21 into A32 minus A31 into A22. Similarly, we can expand the determinant along the second row. Determinant value of matrix A is minus 1 raised to the power 2 plus 1 into A21 into determinant obtained by hiding the second row and the first column, and this determinant is A12, A13, A32, A33 plus minus 1 raised to the power 2 plus 2 A22. Now we will hide the second row and the second column, and here we'll write the determinant obtained by so A11, A13, A31, A33 plus minus 1 to the power 2 plus 3 into A23. Now we will hide the second row and the third column, because we are multiplying by A23. So the resulting determinant is A11, A12, A31, A32. Finally, we'll have minus A21 into A12 into A33 minus A32 into A13 plus A22 into A11 A33 minus A31 into A13 minus A23 A into A11 A32 minus A31 into A12. So this is the expansion of the given determinant along the second row. Similarly, we can find the expansion of this determinant along the third row, and similarly we can expand it along any column also. Let us see how to expand this determinant along first column. Determinant A is equal to minus 1 to the power 1 plus 1 into A11. As our key element is A11, so we'll hide first row and the first column, and we'll multiply this key element with the determinant obtained by hiding the first row and first column of 3 by 3 determinant. Determinant we obtained is this: A22, A23, A32, A33. Plus minus 1 to raised to the power. Now we are expanding this determinant along the first column. So minus 1 to the power 2 plus 1, A21 will be the next key element. So we'll hide the first column, of course first column, because we are expanding along the first column, and the second row, because this is our second key element. Now the remaining 2 by 2 determinant is A12, A13, A32, A33 plus minus 1 raised to the power 3 plus 1 into A32. Now we will hide first row and the third column. First row and the third column. So the resulting determinant will be A12, A13, A22, A2, A23. Finally, we'll have A11 into A22, A33 minus A32, A23 minus A21 into A12, A33 minus A32 into A13 plus A32 into A12 into A23 minus A22 into A13. This is the determinant value of the 3 by 3 determinant when we expand it along the first column. Keep in mind that numerical value will remain the same whether you expand it along first row, first column, second row or second column, or for that matter along any row or any column. So we'll select the row or column as per our convenience. Now let us solve some problems. We have a determinant here, 3 minus 1 minus 2, 0 0 0 minus 1, 3 minus 5 0. Now if you observe this determinant, you will find that the second row has two zeros. It means that expanding this determinant along second row will be easier because its two factor will be 0. So we'll expand this, expanding along second row. We will get 0 into minus 1 minus 5 minus 2 0. This sign will be negative because we are in the second row and first column, so the sign will be negative. Next element will be positive because this is second row and the second column. 2 plus 2 4, second row and the second column, so 0 will be multiplied by 3 3 minus 2 0, and last one is minus 1. Second row third column, 3 plus 2 5, odd number hai, so this should be negative, so negative of negative is positive. 1 into 3 3 minus 1 minus 5. This will be the expansion of this determinant along the second row. Here I have written 0 into these determinants. In actual practice you need not to write this because you know that if you multiply any number by 0, the product is always 0. So simply you write 0 0 at these two places and solve the third part only. We'll get 1 into 3 into minus 5 minus 3 into minus 1, and the answer is minus 15 minus minus plus 3 is equal to minus 12. Minus 12 is the answer. Let us solve one more problem. Find the value of x. Find the value of x if determine 2 4 5 1 is equal to 2x 4 6x. Had it been matrix, we would have compared the corresponding elements, like this 2 is equal to this 2x, and this 4 is equal to this 4, this 1 is equal to this x. But this is not a matrix, this is a determinant. If two matrices are equal, then their corresponding elements are equal. This is not so for determinants. For determinants we have to solve completely. So solving both the side or finding the value of determinants on both the side, we'll get 2 into 1 minus 5 into 4 on the left side. On the right side we'll have 2x into x minus 6 into 4. This is 2 minus 20. This is 2x square minus 24. 2x square is equal to minus 18 plus 24. 2x square is equal to 6. X square equal to 3. X equal to square root of 3 or plus minus root 3. This is the answer. So that's it in this video. Thank you.